everyone. Today I'm going to talk about this form log utility, how this utility work in OpenFOAM. We can we can utilization of this utility to get the to extract the variable in the XY format. So we will see in later on. So these are the two command I have mentioned here: foamLog and foamLog hyphen. You can hyphen help. You can get the help. You can get the some information when you open the terminal. Just execute this command. You will get the some options after executing this command. So yeah. So basically foamLog it is used to extracting the variables from a case in OpenFOAM. It means we will see in later in this demonstration. I will talk about how what does it mean of this. So that is see here also. So if you open the terminal and execute this command, you will get some information. Basically it will show the what are the options are available when we use this utility foamLog. So we will see in next slides, next coming slides. So here is one picture shows that it is basically it is the case study case which I have done, and it will show then that basically this is a by default tutorial I have executed here. So just the main motto to demonstrate here. First you can see here there is a one tutorial case which I have copied from the source code of OpenFOAM. Then you can see here the elbow, basically is this elbow tutorial we have copy and execute this. These are scripts, so that whatever application in the sense whatever utilities or application you can say is run, then it's saved in the log form, like here icoFOAM solver is used and used. So then it's all the information iteration information is saved in the log file. We can see in the next few slides. So one problem is considered which I am going to demonstrate here by using a solver that is called icoFOAM. Basically this solver it is used for the tangent simulation, tangent flow to analyze the tangent flow, and this solver it is used for incompressible flow. Yeah. So let's see this foamLog utility. It is used to extracting the field variable or extract the data of each time step from the log file for a graph in a for the case. So it's what does it mean when we have like it depend on that it depend when we have the steady state simulation, then we don't have the time step data, just we have the iteration wise data. All the data is saved in iteration wise, so we can say that the all the iteration wise data, that because that all data all the like whatever iteration is happen, it's saved in the log file. So and that log file it contains all the variables like pressure field, velocity field and velocity field, so etc. So then that log file is concerned, so we can extract that field variables from the time step from the time for the time step, like when we have the tangent simulation, then data all the time directives data is there. If we have that steady state simulation, so then we have the iteration y data. So that is the meaning. So all the log when we use this utility, so then we can see in later. So I will explain to you. So yes. So suppose for here for see we have like I have considered one case, so that it is basically it is there in an OpenFOAM tutorial folder. Then you can copy into the your run directory. Basically if you execute this variable, so you will get the you will go to the run directory. Yeah, so in your directory you can copy that this tutorial, you can copy this tutorial into your run directory. So then, so and basically this is the standard case you can get easily. Just execute this and you will get as the, and you don't need to change anything. But yeah, so our motto is to only demonstrate this command, this utility, how we can use of this. So yeah, so when we have executed similar case, so then it all the data is or whatever command we have executed, that is saved in the log file files. So like when we have for this case we have used this use this tutorial elbow tutorial case for the demonstration. So when we execute, it contain all the file basically. Then if you execute the all run, because it has the all some scripts and directories. So then then when you execute all run, then you will get the then after that you will get the log files. So I'll explain to later in this next slide. So that we have the log in the we have the log file in the case directory. So then we can execute this command. So what it will what it is what will do what will it basically it will extract the data, extract the variable which is stored in this file. So let me explain the next few slides. So like we have the, like I said, if we have if we want to analyze the simulated results for the case, log file can be used for the runtime or post processor to extract variable from the log file, as I already talk about this. And the result file or executed data can be opened, that whatever executed exported or data for the variable, it can be open in the other tools like Excel, LibreOffice, Generate, or you can use that Python for this. And yes, so there are several tools which depend on the user, which user wants to so basically you have the xy data in the sense, suppose for this case, like we have the for this case, like all the time, basically all the time data with respect to this how this when the simulation is happening. So then how this and the field variable like pressure, velocity, components, how they are changing with respect to time, so that in the xy format. So you can use any tool, then you can plot that data. So yeah, this is the basic step you have to follow. Yeah, so like step by step I mentioned here. So like we have created one case which is like elbow case. So then that elbow case yeah, that elbow case you can change the yeah, you can change change the name of that tutorial. So basically that standard format, and you can use any tutorial to demonstration for this. You can no problem, you are free to take any tutorial. So basically it will work in the whole tutorial. Just you have to have log file. Just we need to get we need to know, we need to get some information how we can extract the variable, extract the variable from the log file. And it contains, this log file, it contains several variables. So this is a basically standard procedure, step by step. Like we have the case folder, case directory. So then we need to set all the input information, like we have to give the initial condition, like in the time zero directory, if the tangent simulation, and if you are taking this steady state simulation, then you have the some at initially flow field variable at zero iteration. Then yeah, and you can have this constant folder, there is a geometry information, that you have to have you have to have all correct information how we can get the mesh from that. Yeah, all the information you can use for this, in this case, basically what it is, what are the procedure process are applied in this in this tutorial. So basically in this tutorial I will explain later, just in the next few slides, next slides. So basically this is the standard format. We have to execute the solver in this tutorial we have executed this icoFOAM, then this icoFOAM file is generated. So all the information, and after that all the simulation, the case simulation is get over. So then you can and parallel you can you can proceed these processor. So I mentioned here, run. When we have run, just we can take the help, so you can see what are the options available. And if you can execute, then the log, basically if you execute foamLog icoFOAM, then one directory will generated, that is the logs. Basically the s is missing here. Basically that directory logs, logs, logs directory, logs name directory will be generated, and see all the exported data is saved into that in this directory. So let me explain here. So when we have the tutorial case here, like here, so then when we execute this command, so it will show like that. This is the basically this is our case, current case for the which we have considered for the demonstration purpose. So then just only you need to execute this script, all run script. So then all one by one, all whatever application are executing in this script, so all the information saved in the log file. So suppose in this for this case, basically in this case what we have the mesh file here, so which is another software from this mesh file is created in another software like Fluent. So that mesh we are that mesh is contain all the geometrical information. So that geometrical information which is created in another software, we have to export into the OpenFOAM format. So then we can execute this Fluent mesh to form. So firstly, then if you execute this command, so all this command will generate it, this file will generate it, log fluent mesh to form this file. After that, then we have the mesh is already generated. So next we need to we have to set all the information. We have not changed in anything in this tutorial. Okay, we have just by default all the settings. So now we have another second step is solver execution. So what the solver is used here is icoFOAM. So that's what this log.icoFOAM file is generated. So now, and second, for then these are the two other options, two other commands are executed in this this tutorial case. Like I see like we have all the case in OpenFOAM. We have done this case in OpenFOAM. Then we can export the data for data from the OpenFOAM to another software like Fluent and others. So now you can export this form data to the Fluent form mesh to form mesh information to the Fluent information again. So yeah, so that's what these two command, form mesh to Fluent, this whatever case is, that case we have considered here. So all the mesh information is, it will export into the Fluent format. So then another form data to Fluent. So whatever data, like mean this for the time directories, so 0 to 10 time directory data is generated after simulation. So this data can be it can be exported into the Fluent format by using this form data to Fluent. If you execute this command, then these are the this log file will generate, and another one folder is also generated, this fluent interface data. In this folder all the information are saved, which after execution these two commands, form data to fluent, for mesh to fluent. Yeah. So our motto is now our motto is to do how we can utilization of this form log utility. So then that is the standard process to run. So like we can write this form log name of the utility, then we have this file, this contain all the field variable which we are going to extract. So when we executed this, then this file, after that this as you can see all the logs directory. So as you can see, if you execute them, there are some option or information will be running after execution. So you can see that here. So what is said the execution, when we execute this, so the all the information, then this logs directory is generated. Like you can see here, we don't have the log directory here, logs directory, but after execution this we can see here. So there is a log file is also generated which contain all the this data, whatever xy files generated, like it said now, like it said generated xy files for clock time. Clock timing at like we have the we have the time series data here, like 0 time, sometimes 0 time, 1 time, 2 time, 2 second, 3 second, 4 second. So then what is the clock time, what is the accumulation time, what is the correct, this way all the information are exported. You can see here, if you go, if you can see this after execution, you can see this logs directory generated. So in that directory generated, you can have a look what are like what are all the whatever like you said, right, generated xy files, whatever is here, all the information is generated and it will save into that log file. So like here I said this all the like pressure, velocity, and all that iteration data. So this is the in xy format. Xy format in the sense that is the that we call the standard format. Like we have the one variable and we have the values of that a particular. Yeah. So that data, like we can see here, like we can pick one data. So basically if you see if you go there in the this log directory, then you can open xy this x component of the velocity. You can see at the different, you can see here the time on x-axis and how this velocity is changed with respect to time. So basically like we can see here the convergence, how this behavior of this velocity or pressure with respect to time you can plot and you can see. Yeah, these are the useful link. You can have a look for the more information. So thank you for watching.